All right, guys. Let's do a few more problems of mathematical induction. Okay. So let's start. Do you know the difference between sequence and series? Do you know the difference? What is sequence and what is series? You don't know. Okay. So sequence sequence is a progression of numbers which follow some pattern. For example, 1, 3, 5, 7. So in this sequence, what is the pattern? This sequence, what is the pattern?
Difference of 2 with the initial value of 1.
Yes. What is the pattern of this sequence? Simple. Twice n plus 1 and greater or equal to 0. This is the pattern of this sequence. It is generating all the odd numbers. On the other hand, series is a
স্যার এটা 2xn প্লাস 1 হবে আর 2xn মাইনাস 1 হবে
আমি তো n
বিকজ
greater or equal to 0 দিয়েছি।
আচ্ছা
Series is a sequence।
স্যার ক্যামেরাটা একটু বাইরে নিয়ে গেলে ভালো হয় স্যার, দেখা যাইতেছে না।
কেন দেখা যাবে না?
ওয়েট
আপনি
হোয়াট
তো
স্যার
একটা
অর্ধেক কেটে
মাঝখানে
আছে।
লিখছে, মাঝখানে লিখছে, আপনি পিন করেন, পিন করলেই দেখতে পাবেন। Is everybody all right? Can you see
ইয়েস
the page?
ইয়েস স্যার
Yes, sir.
Okay, okay.
স্যার
A
জাস্ট ব্লারি
sequence
ব্লারি হয়ে যাচ্ছে মানে প্রতি সেকেন্ডে সেকেন্ডে ব্লারি হয়ে যাচ্ছে অনেক
that is because of internet actually.
ইয়া এখন ঠিক আছে ইউ ক্যান কন্টিনিউ
Okay. A sequence of numbers connected with some algebraic operators. For example, let's say 1 plus 2 plus 3 plus dot 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 dot. So this is a series. And this series can be represented as a summation sign, summation of I equal to 1 to, let's say, it up to n. So n. So that is the difference between sequence and series. In series, the sequence is connected with some algebraic operators. Okay. Now, a very important series in mathematics is called harmonic series. Harmonic series. Now, what is harmonic series? Harmonic series is like this: 1 plus 1 by half plus 1 by 3 plus 1 by 4 plus dot 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 1 by n. So term, each term in the sequence so it means if you want to find out the second term in the sequence, it is nothing but 1 by that term. So if you talk about third term, this is the third term. which is nothing but 1 by 3. And as it is a series, it is connected with addition operator. This is nothing but summation of 1 by I equal to 1 to n. So this is a very important series. This is called harmonic series. In fact, this is most probably the most important series in the mathematics. And there are a lot of interesting problems with this harmonic series and the generalization of harmonic series. Now let's try to prove this. Prove that h to the power 2 to the power k smaller or equal to k plus 1. How can you prove this? We can use mathematical induction. So what can you do? Step 1. For n equal to 1, h 2 to the power 1, which is nothing but h2. By the way, this series can be represented also by hn. So the first n terms of harmonic series are represented by h. So h2n, which is nothing but 1 plus half. So left hand side is equal to 2,
1.5. 3 by 3.
3 by 2. Right hand side is nothing but 2 plus 1 equal to 3. So left hand side is smaller equal to right hand side. So step 1 is done. Base case.
Sir, right hand side 2 plus 1 0.
K plus 1. Oh, okay,
What?
okay. Yes, right. No. You're right.
Yeah.
2 to the. So you're right. You are right. I made a mistake. Right hand side should be 2 to the power 1. The power is actually exponential power is actually the k. So right hand side would be 1 plus 1 equal to 2. That's the thing.
Exactly.
Yes, thank you. Now step 2. Inductive hypothesis. For n equal to m, assume true. So h e to the power m smaller than equal to m plus 1. Now let's go to inductive step. For 1 equal to m plus 1, we have to prove that h to the power 2. So we have to prove this. So how can we prove this? How can we prove this? So we know h to the power 2m smaller than plus 1. Now h to the power 2m
Into 2.
plus 1 by 2m plus 1 1 by twice m plus 2, 1 by twice m plus 3, dot, 1 by twice m plus twice m, smaller than equal to 1 by twice m plus 1, twice m plus 2, 1 by twice m plus 3, dot, 1 by twice m plus m plus 1. That means in both sides, whatever our inductive hypothesis in both sides, I have add all these terms, equal terms added. So nothing would change. Now what is this? What is this?
H
So up to 2 to the power m. Here we have up to 2 to the power m. Then I add 2 to the power m plus 1, 2 to the power m plus 2, up to 1 by 2 to the power m plus 2 to the power m. So 1 by 2 to the power m plus 2 to the power m is nothing but 1 by 2 to the power m plus 1. So what would be the left hand side? This is nothing but
sir 1 by 2 to the
h
power, sir 1 by 2 to the power m.
m plus 1. The whole left hand side would become this. Now what would be the right hand side? এটাকে আমি লিখতে পারি কি? So how many 2 to the power, how many terms are there here? How many terms are there? এখানে in this from here to here, how many terms are there?
M.
No, 2 to the power m. Number of terms equal to 2 to the power m. Okay. Now let's take a term which is smaller, which is actually greater than all this term. That term is nothing but 1 by 2 to the power n, and multiply with this with 2 to the power n. So then the equality sign would not change, and keep that as it is. So h 2 to the power m smaller or equal to m plus 2. So we are done. Good.
স্যার আমি এটার মানে ইয়ে বুঝিনি, এয়ারপোর্টের বুঝিনি।
বুঝি না
আমি বুঝিনি স্যার, H2 লাইক H2m লেস দ্যান m প্লাস 1 এটার পর থেকে বুঝিনি।
কোনটা থেকে বুঝি না
লেফট সাইডের we know H2m less than or equals to m plus 1.
হুম।
এটার নিচে কি করেছে?
কেন বোঝা যায় না? Let's say like this. 1 plus half. What is this? H2.
H2
এখন if I add 1 3 plus 1 4 plus 1 5, what is this? This is nothing but H2
H5
plus 1 by 3, 1 by 4 plus 1 by 5. This become H5. The same thing. We have add from 1 by 2 to the power m plus 1 up to 1 by 2 to the power m plus 2 to the power m. Same thing happening here. Got it?
স্যার তাহলে এখানে আমি অ্যাড করছি কি 1 বাই 2 টু দি পাওয়ার m
This
প্লাস
whole
1 না?
this whole
হ্যাঁ,
thing.
এই পুরোটা 1 বাই 2 টু দি পাওয়ার m প্লাস 1 না?
হ্যাঁ পুরোটা 1 by 2 to the power m হবে না, শুধু এই টার্মটাই 1 by 2 to the power m plus 1.
হ্যাঁ, m প্লাস 1।
Last টার্মটাই শুধু, only the last term is 1 by 2 to the power m plus 1, only the last term.
আচ্ছা,
So it is done. So we add it here. Then এটাকে কিভাবে লেখা যায়? মনে করেন here is like this. 1 by half plus 1 by 3 plus 1 by 4 plus 1 by 5. এগুলো প্রত্যেকটা চেয়ে হাফ বড়। তাহলে আমি যদি এগুলো প্রত্যেকটাকে হাফ দিয়ে রিপ্লেস করি তাহলে আমি কি পাবো? 1 plus half plus half plus half plus half. And how many half are there? 3, because 1, 2, 3. So it is nothing but 1 by half plus 3 by 2. This is the same thing I done there.
আচ্ছা আর স্যার এখানে নাম্বার অফ টার্মস টু টু দি পাওয়ার এম কিভাবে হয় লাইক আমরা কি এটা
এখানে
ডিসক্রিট
একটা 1, 2, 3 up
ও
to
আচ্ছা
2
আচ্ছা
to the
আচ্ছা
power.
গট ইট
Okay?
গট ইট
So let's go to next problem.
স্যার আমাদের আর কয়টা টপিক বাকি
আমাদের আরো ভালো টপিক আছে।
স্যার আমাদের ফাইনাল কবে হবে
You will know soon. Now let's go to solve another problem. Prove that summation of hj j equal to 1 to n is equal to n plus 1 hn minus n. You have to prove this. J equal to 1 to n, hj equal to n plus 1 hn minus n. You have to prove this. So how can you prove this? Again the same way. Yes. Step 2. Assume for assume for n equal to m, summation of j equal to 1 to n hj equal to m plus 1 hm minus m is true. Step 3. For n equal to m plus 1, we have to prove summation of hj j equal to 1 to m plus 1 is equal to m plus 1 plus 1 h m plus 1 minus m plus 1. So we have to prove this, which is nothing but summation of hj j equal to 1 to m plus 1 m plus 2 h m plus 1 minus m plus 1. We have to prove this. Okay, so how can I prove this? Any idea? Any idea, guys? So let's take this. We know j j equal to 1 to m is nothing but m plus 1 hm minus m. Alright, so let's add both sides. Aj j equal to 1 to m plus hm plus 1 m plus 1 hm minus m plus hm plus 1. So both sides we add this term. This is nothing but hj j equal to 1 to m plus 1. Now we have to convert this to this. How can I convert this to this? Any idea, guys?
স্যার আমরা নিচে লাইক লেফট হ্যান্ড সাইডে সামেশন এম প্লাস ওয়ান এইটাকে তো ব্রেক ডাউন করলাম, আবার এই ইয়েটা কেন লিখলাম? আমরা এখানে যদি ফার্স্ট লাইনের উইন ওর ফার্স্ট লাইনের এইটা রিপ্লেস করে তাহলে প্রুফ করতে ইজিয়ার হতো না?
কোনটা করলে ইজিয়ার হতো বলেন, স্ট্র্যাটেজি বলেন, টেল মি দ্য
হ্যাঁ,
স্ট্র্যাটেজি।
এই যে স্যার সামেশন অফ এইচ জে জে ইকুয়াল
হুম
টু 1 টু m ইকুয়াল টু m প্লাস 1 hm মাইনাস m।
হুম
আমরা সেকেন্ড লাইনের যে সামেশন অফ এইচ জে এম জে ইকুয়াল টু 1 টু m দিয়েছি, ওইটার জায়গায় m প্লাস 1 hm মাইনাস m দিয়ে করতে পারতাম না?
করতে পারতেন, এটা আপনার আপনার ইচ্ছা, আমি এইভাবে করছি। হতে হ্যাঁ ওটা হতে পারে, লজিক্যালি দ্যাট ইজ অলসো কারেক্ট। তারপর আপনি ওটাকে রাইট সাইডে নিয়ে গেলেন মেবি, বাট আমি এইভাবে করি, আমারটা মতো করে করি।
ওকে স্যার।
একভাবে করলেই হলো, বাট দ্যার ইজ নো fallacy in your one as well. If you come up with correct answer, that will be also fine. আচ্ছা আমার এটা হয়ে গেছে, এটা হচ্ছে আমি এটাকে এইভাবে লিখতে পারি, m plus 1 hm 1 by m plus 1 minus 1 by m plus 1 minus m plus h m plus 1. Okay, now what is this? This thing is nothing but h m plus 1. So nothing but h m plus 1. Okay. So we can write this is nothing but m plus 1 h m plus 1 minus 1 by m plus 1 minus m plus h m plus 1. It is nothing but m plus 1 h m plus 1 plus h m plus 1 minus 1 minus m. So it is nothing but m plus 2 h m plus 1 minus m plus 1. So it is nothing but summation of hj j equal to 1 to m plus 1. So we are done. Proved. Guys, anything else? Okay, but let's do a very funny problem. Let's do a very funny problem. The problem is like this. Any integer greater than, greater or equal than 15 can be represented only the summation of 3 and or 8. Is the question clear to you guys?
নো স্যার, কোশ্চেনটা বুঝিনি।
Let's give me a number greater than 15. Let's give me any number greater than 15.
20।
20. So 20 can be represented like this. 3 plus 3 plus 3 plus 3 plus 8.
ও আচ্ছা, বুঝছি।
Only the summation of 3 and 8. But how can you prove this? How can you prove this? So let's see the proof. It will be like this. For n equal to 15, 15 is equal to 3 plus 3 plus 3 plus 3 plus 3. So base case. So numbers. Let's say step 1, base case. So base case we can prove for base case it is true. Now let's do the step 2, inductive hypothesis. Inductive hypothesis. Assume for n equal to m, the statement is true. Statement is this one. This is the statement. Now step 3. Inductive step. What would be the inductive step? We have to prove for n equal to m plus 1, the statement is true. Okay? We have to prove for n equal to m plus 1, the statement is true. If there is any 8 in an m, then we can replace 8 with 3 threes. Then we get m plus 1. Did you get it?
না স্যার, বুঝিনি।
মনে করেন 20 তে একটা 8 আছে। Am I right?
হ্যাঁ
20 তে একটা 8 আছে। তাহলে আমরা কি করতে পারি? If I replace this 8 with 3 threes, তাহলে এখানে আমরা অ্যাড করছি +1
হুম
and বাকি যা আছে let's keep that intake. Then what would be the number? What would be the number? 21.
হ্যাঁ
Am I right? The number would be 21. And in this construction, 21 contains all the 3. Do you agree with me or not?
হ্যাঁ
Right?
হ্যাঁ
Tell me something. Otherwise, I don't understand.
Yes sir, right, right.
So, then we get m plus 1 and it contains it contains 3 and or a's only. If there is no 8, definitely there are more or equal 5 threes. Do you agree with me or not?
Yes, sir.
If there is no 8, definitely there will be more or equal 5 eights,
Yes, sir.
5 threes, because 15 has 3 fives, 3 5 threes. If you take any other bigger number which does not have any 8, definitely it must be represented with 3 and 8 before, and definitely that must have more than 5 threes. So then replace 5 threes with 2 8, 2 eights. Did you get it? Replace 5 threes with 2 eights. So what is the catch? It is like this. So we are going to take 5 threes. 1, 2, 3, 4, 5. So 15 is replaced with 2 into 8 equal to 16. So what is the number? The number will be like this.
M plus 1.
22 is nothing but 8 plus 8 plus 3 plus 3. So again, so this is the number one construction, number one case. It is the number two case. Again, it contains T and or A's. So done, proved. So this is one of the method. This is how you can prove
স্যার
this.
এইটা আবার একটু শুরু থেকে একটু ব্রিফলি বুঝাবেন?
কোনটা বুঝাবো? কোন পয়েন্ট?
মানে এইটা জাস্ট ব্রিফলি একটু পুরোটুকু
ব্রিফলি
একবার।
এই যে একটা এক্সাম্পল দেই। 20. So if 20 is actually my inductive hypothesis, I have to prove 21. So how can I prove this? 20 is nothing but 4, 3, and 8. So there is 8. So that's why we replace this 8 with 3 threes. Then we are increasing by plus 1, we get 21. Then it only contains 3 and 8. On the other hand, if there is no 8, let's take 21. So we are going to replace 5 threes with 2 eights. Then again, we get plus 1, it is 22, but it also contains only 3 eights. Did you get it?
Yes, sir.
Okay, we can prove it some other ways also. How? So let's take this. So far, all the examples I have given, those are actually examples of quick induction. So what is weak induction? Weak induction is like this. Weak induction is we assume a base case, then Sn, we are considering Sn in true, and we assume uh, sum and Sn is true. Using these two, we are trying to prove Sn plus 1 is true or not. If this is the case, then we can say for all n, Sn is true. So this is the inductive hypothesis. Weak induction hypothesis. Okay. Strong induction hypothesis is little different. Strong is like this. Strong induction is it will assume multiple base case. So S1, S2, S3, dot dot dot, Sn. Okay.
Yes, sir.
Then using all this S1 and S2 and S3 dot 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 Sn for sum n, we are trying to prove Sn plus 1 is true. Then ultimately it also becomes all n Sn is true. So the difference is in weak induction, using Sn, we are trying to prove Sn plus 1. On strong induction, from 1 to n, we are trying to prove Sn plus 1. But they are equivalent. So weak and strong are equivalent. We can easily prove that. Okay. Same. They are same. Now, using strong induction, this problem can be solved more easily. How can I solve it? Tell me. Do you have any idea?
No, sir.
No idea?
না স্যার এরকম করিনি তো, আর মানে স্ট্রং ইন্ডাকশনের আগে করিনি তো, সো
আচ্ছা,
একটা
strong induction আগে করেন। So same problem for integer greater or equal to 15, continuation. For and greater or equal to 15, we have to prove all numbers can be represented with 3 and 8. So let's take 15. 15. So what is 15? 3 plus 3 plus 3 plus 3. Okay. Now let's take 14. What is 14? আমরা এক step আগে যাচ্ছি because we are going to see why we are going back. Though you have to prove and greater or equal to 15, we are going back. So how can I represent 14? Any idea? How about this? 3 plus 3 plus 8. Let's go back to 30. What is this? How can I represent this?
স্যার এগুলো না এন লেস দ্যান 15 হয়ে যাচ্ছে।
হ্যাঁ, সেটাই তো বললাম। আমি একটা বিশেষ কারণে আগে যাচ্ছি। একটা বিশেষ কারণে আগে যাচ্ছি।
স্যার এটা তো রিপ্রেজেন্ট করা যাবে না এর দিয়ে।
13 কে যাবে না করা?
যায় না তো। 8 plus 3 is মানে 13 is not a multiple of 3, then again 13 8 plus 3 is 11, আবার 8 plus 3 plus 3 is 14, মাঝখানে 13 মিসিং হয়ে
আচ্ছা,
যাচ্ছে।
ঠিক আছে, বাদ দেন। 16, 16 কে রিপ্রেজেন্ট করা যায়
8 plus 8।
8 plus 8। তাহলে এটা যদি কে হয়, এটা হচ্ছে কে মাইনাস 1 আর এটা হচ্ছে কে মাইনাস 2। ডু ইউ এগ্রি উইথ মি অর নট? So this is my base case. Now step 2. Step 1, assume for n equal to 14 up to m, it is true. Okay, n equal to 14 up to m, it is true. Well, definitely sm is true. Do you agree with me or not? S m minus 1 is true. Do you agree with me or not? S m minus 2 is true. Do you agree with me or not?
Yes.
Right?
Yes.
Where? What is the value of m? M is greater than m minus 2. So m is greater or equal to 16. Right? Right?
Yes.
Now, m minus 2 plus 3. What would be the number?
m plus 1.
So, m minus 2 is already represented summation of 3 and 8 only. Then I add with this another 3. Then what is the catch? What is this number? M plus 1. Am I right? So what is the catch? What is the catch? M plus 1 can be also represented using
8 and 3.
3 and 8. So this is the combination. So this is using strong induction. Okay? Do you have any query?
স্যার অনেকটা কনফিউজিং লাগতেছে, লাইক কি করলাম, একটু দাঁড়ান, একটু হোল্ড করেন।
Confusion লাগার কিছু নেই। Strong induction হচ্ছে কি all those are valid. From starting point, starting base case up to assumption, all can be considered true and you can use all those. So that is the strong induction. Okay? And here what we did actually. So for proving for 17, we will add 14 plus 3. For proving 18, we are going to add 15 plus 3. So this way we will continue. Okay. All right. So
স্যার
let's try.
এটা মানে লাস্টের দুইটা দুইটা নিয়ে করতে হবে তাই তো?
হ্যাঁ, লাস্টের দুইটা দিয়ে, কারণ 3 যোগ করতে হবে তো, তাহলে
আচ্ছা
14 plus 3, 15 plus 3, 16 plus 3. This way you have to continue. Okay. Done.
স্যার কিন্তু আমাদেরকে তো এখানে n এর কন্ডিশন দিয়েছে n গ্রেটার দ্যান অর ইকুয়াল টু 15, তাহলে আমরা মানে 14 পর্যন্ত কেন নিলাম?
গেলাম কারণ 17টা প্রুভ করার জন্য। আপনি 14টা যদি প্রুভ না করেন তাহলে আপনাকে 16, 17 থেকে শুরু করতে, 17কেও বেস কেস ধরতে হবে।
আচ্ছা
কারণ 15 প্লাস 3 তাহলে হয়ে যাবে 18। তাহলে 18 থেকে আপনি ইন্ডাকশনটা করতে পারবেন, এই স্টেপটা করতে পারবেন। বাট আমি 17 থেকে শুরু করার জন্য 14 পর্যন্ত ধরে নিচ্ছি। ওকে,
আচ্ছা
তো দোজ আর ট্রিভিয়াল। আচ্ছা, এবার আরেকটা প্রবলেম করাই। রিকার্সিভ ফাংশন। হোয়াট ইজ রিকার্সিভ ফাংশন? ডু ইউ হ্যাভ এনি আইডিয়া অ্যাবাউট রিকার্সিভ ফাংশন? What is recursive function? The recursive function is nothing but inside the definition of a function,
there is another function,
not another function.
there is
Inside the
itself.
definition of the function itself is known. The function itself is present. Can you give me an example of in recursive function? We already know one, very familiar with that function. Factorial. N factorial is nothing but n star n minus 1 dot 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 3 star 2 star 1 and 0 factorial equal to 1. Now if you consider only this part, what is this? This is nothing but n star n minus 1 factorial. So n factorial is nothing but n into n minus 1 factorial. So if you consider factorial as a function, factorial n is nothing but n star factorial n minus 1. And for each recursive function, that should have a terminating state. And in this case, it is nothing but factorial 0 equal to 1. So this is the recursive definition of it. Do you get it? Come on, guys. Any query?
তার নেট মানে আমি যেটা দেখবো এটা এতটা ব্লাডি হয়ে গেছে কিছু মানে বুঝতে পারতেছি না, নেটে এত সমস্যা করতেছে।
Okay. So this is the definition of recursive function. Okay. All right, guys. Now let's do a problem. Another famous problem. Fibonacci sequence. Let's take Fibonacci sequence. What is Fibonacci sequence? Do you have any idea about Fibonacci sequence? Fibonacci sequence. Any idea? Anybody know anything about Fibonacci sequence? So Fibonacci sequence starts from 0. Then second one is 1. Then next one is addition of previous two terms. 1. So next one would be 2. Next one would be 3. Next one would be 5. Then 8. Then 13. This will continue. So Nth Fibonacci sequence is nothing but summation of n minus 1 plus n minus 2, where n is greater or equal to 3, and f1 equal to 0, f2 equal to 1. So this is a recursive function. Did you get it? Why Fibonacci sequence is so important? Do you have any idea what it represents? What it represents? This represents actually the population of rabbit, a population of rat. It's actually the way these animals expand. Okay, so let's try to prove this. Prove that fi summation I equal to 1 to n is nothing but fn star fn plus 1. You have to prove this. Fi whole square, sorry. So how can you prove that? Any idea, guys? So we are going to use mathematical induction. Base case. For n equal to 1, left hand side is equal to 1 to 1 f1 whole square. So f1 is nothing but 0 square summation I equal to 1 to 1. So sorry, আমি কি করছি? Right hand side equal to nothing but f1 star f2. f1 is 0 star 1, which is 0. So left hand side equal to right hand side. Let's go to step 2. Let's go to step 2. What is the step 2? What is step 2? Assume for n equal to m plus 1 m summation of f I square I equal to 1 to m is equal to fm star fm plus 1 is true. Step 3. We have to prove summation of fi square I equal to 1 to m plus 1 fm plus 1 star. Guys, stop creating noise. You have to prove this. So how can you prove that? We know summation of fi square I equal to 1 to m is equal to fm star fm plus 1. Add both case fi square I equal to 1 to m. So add both case f m plus 1. So fm fm plus 1 whole square. Fm plus 1 plus fm plus 1 whole square. This is nothing but summation of fi square I equal to 1 to m plus 1. And this is nothing but take common fm plus 1. What do we get? Fm plus fm plus 1. According to definition, this is nothing but m plus 1 star. So we are done. Okay, so this is the end of mathematical induction. Today we'll start a new branch of mathematics that is actually nothing but number theory and the divisibility. Okay? Do you have any query about mathematical induction? You can ask.
স্যার ম্যাথমেটিক্যাল ইন্ডাকশনে কি আমাদের কি স্পেসিফাই করে দিবে যে কোনটা দিয়ে প্রুফ করতে হবে, উইক দিয়ে নাকি স্ট্রং দিয়ে?
যেটা আপনার ভালো লাগে, যেটা
আচ্ছা।
মন চায়।
স্যার এই যে এটাকে যদি আমাকে স্ট্রং দিয়ে প্রুফ করতে বলতো, লাইক কোশ্চেনেই বলে দিল যে স্ট্রং দিয়ে প্রুফ করতে হবে, তাহলে এটা কিভাবে করতাম?
কোশ্চেনে বলবে না।
আচ্ছা।
আর দুইটা ইকুইভ্যালেন্ট। So you will say if you want to prove something using strong, but you cannot find out, figure it out, then you will prove it weak. But at the beginning, you will say weak induction is equivalent to strong induction. Then you will start your. Did you get it? This is the cheating.
আচ্ছা, নাইস।
Okay. Lot of way you can cheat. So let's start new branch of mathematics, which is nothing but number theory and divisibility. আপনাদের কুইজ কবে?
স্যার
ফাইনান্সের কে? হ্যাঁ,
ওয়েডনেসডে
Next
বলেছিলেন।
class.
number theory. So what we are going to study here, prime numbers and divisibility. Prime numbers and divisibility. So let's talk about this definition. Assume a comma b belongs to g plus and b not equal to 0. Let's say a comma b belongs to g and b not equal to 0. Then b divides a, or b, see the symbol, b divides a, b divides a. What do you understand by this? What do you understand by this? What is the meaning of this? Let's take this. So let's take this. 12, 3 divides 12. 3 divides 12. What do you understand by this?
2 all মানে কি স্যার?
কোথায়?
ও 12।
12. Yes.
3 by 12, which is 1 by 12.
So the meaning is b divides a, or b divides a is nothing but b is a divisor of a. Do you agree with me or not?
Yes.
Or a is a multiple of b. Do you agree with me or not? Yes, no?
হ্যাঁ, এখানে কি b ডিভাইড দিয়ে হবে নাকি a মানে এখানে যেমন
b divides a. b divides a. b divides a means b can divide a. So b is a divisor of a. 3 is a divisor of 12. That means 3 divides 12. Okay?
Yes, yes,
So
sir.
this is the definition of divisibility. Now let's see this theorem. Number one. If B divides A, it is nothing but B equal to, sorry, then A equal to Bn, where A, B, and belongs to G and B not equal to 0. Do you agree with me or not?
Yes, sir.
So if B divides A, then A equal to Bn, where A comma B comma N belongs to G and B not equal to 0. For example, G divides 12. So 12 is nothing but 3 star 4. Same thing. Right?
Yes, sir.
So number 2. If B divides A and A divides C, then B divides C, where A, B, C belongs to G and B not equal to 0 and A not equal to 0. Okay, guys?
Yes, sir.
Number 3. One divides any A and A divides 0, where A belongs to G and A not equal to 0. In this case, A not equal to 0. Okay, guys? Anything else?
No, sir.
Number 4. If A divides any two of X, Y, Z, then it also divides other integer, where A X Y Z belongs to Z and A not equal to Z. জানলাটা আর কি হতে পারে? First number, if A divides B and A divides C, then A divides BX plus CY. Okay, guys? If A divides B and A divides C, A divides BX plus CY, where A, B, C, X, Y belongs to Z and A not equal to 0. এটা একটা এক্সটেনশন আছে। Extension. If A divides B1, A divides B2, dot dot dot, A divides BM, then A divides B1 X1, B2 X2, dot dot dot, BM X1, where A B1 B2 dot 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 BM X1 X2 dot 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 Xn belongs to G and A not equal to 0. Okay, this is the number 6. It is the extension. So here we have only two parts. Here we are generalized. So the conclusion is, if A divides any two numbers, any two integers, then A also divides linear combination of those two numbers. Okay. Last thing, last one. Choi is if A divides B and B divides A, if A divides B and B divides A, then it implies A equal to plus minus B, where A comma B belongs to G and A not equal to 0 and B not equal to 0. Done. I can prove any of this, but today we'll stop here. From next class, we will continue from here. And at the very beginning, we are trying to prove one of these two, one
Uh,
of some of the few of these theorems. Okay? Yes.
as you said যে আমাদের সিলেবাসের বেশ অনেকখানি বাকি আছে,
G.
আমাদের এক্সামটা যদি ক্লাস টাইমে না নিয়ে ধরেন থার্সডে বা অন্য কোনো এরকম টাইমে দিলে তাহলে উই আর গেটিং ওয়ান এক্সট্রা।
কুইজটা দেন আমার মাথায়, আই হ্যাভ দ্য প্ল্যান। আমি জানি যে আমি ইয়ার আগেই শেষ করে ফেলবো।
ওকে স্যার।
মানে আরো 3টা ক্লাস বাকি, তো মানে 2টা ক্লাস নিতে পারবো, তো আই নো দ্যাট আই ক্যান ফিনিশ দ্যাট। ডোন্ট ওয়ারি।
ওকে স্যার।
যেখান থেকে মেজর কোশ্চেন গুলো আসবে সেগুলো শেষ হয়ে গেছে, ঠিক আছে? আর যেগুলো বাকি ওখান থেকে আমরা খুব সিলেক্টেড টপিক পড়াই, একটা দুটো টপিক পড়াই। সো ইউ ডু নট নিড টু ওয়ারি। ওকে,
ওকে স্যার। ওকে। So
2
the
ক্লাস
quiz,
ইজ মোর দ্যান এনাফ টু ফিনিশ। ইয়েস,
so the quiz is on this Wednesday.
ইয়েস,
Okay sir.
থ্যাংক
তো
ইউ।
কুইজটা কি লাস্ট কুইজের মতন হবে?
আগের ইয়ার মতো আমাদের কুইজ, প্রথম কুইজটা যেরকম হয়েছে সেরকমই
জি
হবে।
স্যার, জি স্যার।
আর স্যার
আচ্ছা, লেটস টেক দ্য অ্যাটেন্ডেন্স।
ফাইনালটা তো মিড
হ্যাঁ,
টার্মের
হোয়াট
মতো,
হ্যাপেন?
কোঅর্ডিনেটেড হবে,
হ্যাঁ,
তাই না?
আপাতত সেরকমই ঠিক করা আছে।
আচ্ছা স্যার।
আপাতত সেরকমই ঠিক করা আছে। All right, guys. See you then in the next class. Till then, goodbye.